All right, so this is sort of what the CDF, the joint CDF of this of the random variables R and W looks like for this balls in the urns problem. You can see that I haven't completed it yet, but maybe you'll just sort of get the idea. So this is the R axis right here. See, the R for the number of red balls in your sample of size 3. And then this right along here is the W axis. Okay, I've labeled it up there, but W goes this way. And so this CDF, this joint CDF, takes the value 0 out here. It's flat. Okay, all the way over here. Until if you progress this way, and then finally we get to, let's say, as we move this way, R suddenly becomes 0, or it crosses 0, where R is greater than 0. What's the chance that, if R is some number in here, what's the chance that you see this many or fewer red balls? Well, it's as long as if you're actually up in this square somewhere, then you're actually looking for the chance that you see this many or fewer red balls right here, this, and then this many or fewer white balls. Okay, which is actually the same as the chance that you see no red balls and no white balls. 0, 0. Okay, and we know that chance. It was 0.0476. Okay, so this is it's gonna be this CDF, this joint CDF is gonna be flat right in here. What if we progress up this way? Okay, so we keep R the same. It's 0 or maybe a little bit more, no more than 1 for sure. Or if we move up in this direction and we increase the number of white balls to 1, then here what we actually want is we want the height of the function here, the value of the function here, to be the number or the probability that you would see 1 or less white balls and 0 or less, or 0 or fewer red balls, right? So it's going to be the height of this first one plus the chance that you see exactly no red balls and 1 white ball. Okay, so the function height here is this plus this, and it sort of accumulates, right? And then finally, if we keep on moving in this direction, let's see, I think be about, say, this high. If I come up like so, and I come out like say here. Ta-da. Okay. And this is actually going to be the chance that I see no 0 or fewer red balls and 2 or fewer white balls. That's what I want the height of this block to be. Okay, so maybe I'll indicate that here. All right, I'll put 0.0476 plus 0.2143 plus the chance that I see 0 red and 2 whites, 0.1429. See that? And then I'd have one more, I think, coming up this way, because I can actually see up to 3 white balls. But that's just an additional 1%, so it's not going to be much more. It's going to be a really small addition there, but it's like so. Okay, like that. And actually, it'll go on like that forever, I think. You might want to ask yourself why. But let's get so what is this? It's going to be 0.0476 plus 0.2143 plus 0.1429 plus 0.0119, right? That's the height of that one. Now, let's do a couple more just to get the idea here. The function evaluated somewhere in this region, this is what we really want this to be, is the chance that R, that we see the number of red balls, let's say if I look here, and some number there, that the number of red balls is less or equal to 1.5, and the number of white balls is less than or equal to, say, I don't know, 1/3 or something. That's the same as the chance that the number of red balls is 1 or less, and the number of white balls is 0. So that's going to be this height plus the chance that I see exactly 1 red and no white. Let's see, which is 0.1429, I think. So I'm going to take 0.1429 plus this much. That's about 0.2, I guess. It's this would be probably something like this. Okay, run up this way, and it's going to come across like that. So, la-di-da, do-do-do, maybe a little shading, nice and pretty. So this is going to be 0.0476 plus 0.1429. Okay, it's going to be the height of that. You can see that it's not quite as high as this block here. Okay, maybe we'll do one more. What's the chance then that I see one or less red and one or less white? One or less red, one or less white. What's the chance that I see exactly one red and exactly one white? That's going to be that's the 0.2857, right? So then I would come up from there a little bit. I would come up from there just a little bit. Okay. So I'm not going to draw that. You can see what's going on though is that as you increase in the R direction and as you increase in the W direction, this function is getting sort of stair-steppy, right? It's increasing, sort of going like this, okay? All right? It's okay. And in fact, it satisfies all the properties of a CDF in a sense, right? It's got to be monotone, non-decreasing. It is. Also, the limits as you move to the left in either variable need to be 0, and they are. And then as you go toward the right in either direction, this way or that way, it's gonna go to 1. And also, it should be continuous from the right with left limits. And if we're a little bit more careful here, actually, you'll see that these maybe ought to be like solid lines, okay? And so should these. And then maybe this should be dashed, okay? So that the function evaluated on that line is really up here. And the function evaluated on that line there is really up there, okay? So that this is actually dashed, right? Solid, solid. So that's kind of what what continuous from the right looks like. Continuous from above, basically, from above, and then as I come down this way, continuous from above with left limits. Okay, that's what that sort of looks like. Okay, so I hope that gives you some kind of idea. Of course, this is an incomplete picture,